Hello, everybody. Thank you so much for joining our webinar today. We have a really exciting conversation and live Q&A that we're going to be getting into today, and we'll get started pretty quickly so we can dive right in. But just to introduce the topic, today we are going to be talking about exceeding industry standards, and specifically we'll be talking about Stubbe's Precast and how they were able to cut carbon and elevate transparency through an EPD. So we're joined today by Stephen Van Wyck. He is the QA manager and plant engineer at Stubbe's Precast. Stephen, so great to have you today.
Thank you.
And also joined today by Nick Ghilardi, who is an EPD expert here at One Click LCA. Nick, great to have you.
Thanks for having me, Aileen.
Awesome. So before we get started, I always ask this question in our webinars, which is, what city are you joining from today? So I'd love it if you could go ahead in the chat, let us know where you are calling in from. I expect we have a lot of people from the US and Canada today, but if you are from a different country, please let us know that as well. And looks like we've got Toronto, Denver, New York, Victoria, British Columbia, few more from Toronto, Vancouver. So lots of people, Montreal, all over Philly. This is great. Glad to have you guys all here. It looks like we're spanning both countries. So that is excellent. Now, the next thing I want to do is another question. And I'm actually going to put this up as a live poll. And it is, what sector are you in? So let me publish that real quick. So you can see up on your screen, should have popped up a poll. So let us know what sector you work in. That will help us also as we're talking today. It's great to know who our audience is so we can speak to you a little bit more clearly. So it looks like a pretty good mix. It looks like we do have 43% are in the AEC sector. But we've got about 20% consulting, 20% manufacturing, and then we've got some others in there as well. So great to have you guys all here. As you all probably know, or at least will find out, environmental product declarations and sustainability does affect both manufacturing and AEC. They kind of go hand in hand. So we'll be talking about that today as well. Now, today's webinar is brought to you by One Click LCA, and if you are not familiar with us, One Click LCA is the world's leading construction sustainability software. So we have an easy-to-use LCA and EPD platform. We have access to over 250,000 LCA data sets, so we do have the world's largest database, and our tool works with over 20 integrations that AEC professionals love. And we also have the means to help you comply with over 80 different standards, regulations, and certification schemes. So certifications like LEED or the Toronto Green Standard, which we'll talk about more today, our software can help you comply with those. We've been in business for over 20 years. We power the makers of a zero carbon future. And that's you guys. You are the makers of a zero carbon future. So we're happy to help power your sustainability journey, and glad to have you with us today. So without further ado, I'm going to hand it over to Nick, and he's going to talk a little bit, get us started with what is embodied carbon, what is an EPD, give us some of those basics just in case there's anyone in the audience who is not super familiar with the topic. So with that, over to you, Nick.
Yeah, thank you, Aileen. Hi, everyone. So today I'll be discussing kind of the background on why this is so needed. So first off, what is embodied carbon? I think that's always a great place to start. Why are we talking about this embodied carbon? Well, first, embodied carbon itself is referring to greenhouse gas emissions. It's kind of where we get that carbon portion from, because CO2 happens to be the most widely spread, known, and common greenhouse gas out there. So these greenhouse gases that are coming from the manufacturing, transportation, installation, maintenance, and disposal of these building materials. All that together creates what is the embodied carbon. Now, why is it important for us to find a low carbon construction? Well, it's because of the way that we've approached decarbonization in the past. And in the past, we've focused on decarbonizing our energy grids. And with this graph that you can see right here, while we are decarbonizing our energy grids, it puts a heavier focus on these materials, which is that green portion of the circle that we see that is increasing. It's going to be the materials, that installation, the landfilling of such. And we will see that over time, this will be the dominant factor. So we need to take important notice on why we need to reduce this portion as much as we're reducing the operational. So right now, all construction is to create at least 40% of these emissions specifically by 2030. So construction has a big hand in all these emissions that are coming out into the world, and a big part of that greenhouse gas global warming causation. Now, these cities are expected to double by 2060, which is adding an extra 230 gigatons of embodied carbon. It's hard to kind of visualize that. So really, this adds a whole New York City every 29 days until 2060. That can certainly put that into perspective. So it also puts it into, how are we going to approach lowering this embodied carbon? We know it exists. We know it's in these things. How are we going to tackle that? That's going to be done through a life cycle assessment. So this life cycle assessment, it evaluates what the environmental impacts are when it's associated with, we can view this from a product perspective, a process perspective, or an activity. And this is quantifying the energy and materials used so that we can get the environmental impacts of that product, process, or activity. Now, these life cycle stages, they're very logical and they're broken down for us to be able to pick apart what we can contribute data-wise into. Here on my screen is how all LCAs are kind of broken down for the most part, especially in the construction industry. So we will see it broken down in this type of formatting. And after we've created this life cycle assessment, it's a lot of data, but we need to present this in a more fashionable way. So we do this through what is called an EPD, or an environmental product declaration. I like to think of this as kind of like a food label or a nutrition label that you see on your box. You know, you'll see the protein, the calories, the sodium, and very similarly, if we were to associate the protein to global warming potential or carbon emissions, we could see that breakdown with other environmental impacts, as we see as other things that affect our calories. So these EPDs are meant to be transparent. They are meant to open up on what are the materials included and how is it made. Even though we do talk about this, we do understand that a lot of your stuff is proprietary. So there is all that stuff that is still kept so that you can still have that proprietary information. The aim is so that we can, as manufacturers, empower the AEC industry to make better decisions and reduce their embodied carbon for the building projects. So sounds like a lot of work, sounds like a lot of data, but I will assure you no PhD is required for doing these LCAs. We do make it easy, and we power that through the many tools that we do have. We have a global database, we make it easy to use, we are cloud-based, so you can take us anywhere that you would like. Our internet service, and we also have the training to go along with that as well. It certainly doesn't matter what stage you are at in the AEC, whether you wanted to look at kind of the pre-built or fully built, and that goes for you manufacturers as well, whether you wanted to look at some of your designs or if you've already had a product that's tried and true, we can look at it at any stage with that ultimate goal so that we can currently measure where we're at, so we can find those hot spots to ultimately reduce our embodied carbon and then eventually show our impacts to our clients and our neighbors so that we can report the good that we have done. And where we are currently at in our embodied carbon stage. And that is currently the background that we do have for the embodied carbon portion. Thank you.
And I'm just going to jump in here real quick. Stephen, I'm going to hand it over to you in just a moment. But I did forget to mention earlier that we are going to have time for live Q&A afterwards. So if you guys have any questions that you think of as you're listening to the presentation, if you want to know more about the project or about EPDs in general, put your questions either in the chat tab or the questions tab. I'll be monitoring both of those, and we'll pull questions from there during the live Q&A. So please definitely send those questions in. And with that, Stephen, I'll hand it over to you to present your case study.
Thanks for that. So my name is Stephen Van Wyck with Stubbe's Precast. I'm the quality assurance manager and plant engineer, as mentioned. We've been with Stubbe's, so a bit about myself, been with Stubbe's Precast for about 10 years. Started with engineering, quickly moved on to a quality assurance role, where I take care of all the quality assurance program here at Stubbe's, ensuring that we meet the certification requirements to stay certified. I also do all the mix designs and optimizing our mix designs and materials, and do a lot of research and development here at Stubbe's as well. Looking at new materials, whenever we look at new materials, so I'm the first one that'll take a look at it, analyze the properties of it, and then also we do research and development on different stuff if we try to optimize maybe connections in our buildings or stuff like that. I'm also actively involved in the concrete precast, the Canadian Precast Concrete Institute and Concrete Ontario on various committees with the sustainability committees, student education for some of them as well. So a bit of an agenda here. I'll get into just a real quick introduction of Stubbe's Precast, who we are, a bit of our history. Then we'll talk about sustainability and EPDs and what we did at Stubbe's here. And then I'll go over a whole building LCA that we did on our new fast track building system that we have in a total precast concrete and the results of that. So a bit about Stubbe's Precast. We were founded in 1982, been around for about 43 years. We are a family-owned company. Started in the agriculture market, making precast hog feeders, precast concrete hog feeders originally. Slowly they expanded into other products such as feeder bunks, T-walls, and slats, also for the ag market. In 2001, Stubbe's expanded into the precast hollow core market, producing hollow core floor slabs. From there, in 2006, they added the capability to produce structural wall panels and cladding wall panels. In 2010, a couple years later, we added a beam bed so we could start doing beams and columns, and then double T's as well. So basically, now that we have the capability, we can produce the entire building in a total precast concrete. So that's the flooring, the walls, columns, balconies, and the entire superstructure of a building in total precast. And that makes up either a total precast structure or fast track, which I'll get into a bit later as well. And then recently, in the last couple of years, we've actually started installing windows in the panels in our plant before we even ship into site to close out the building immediately on site and reduce trades on site as well. So getting into sustainability and the EPDs. So around 2018, 2019, we're starting to see more and more requests from architects and owners about sustainability, basically asking, okay, what are you doing as a company to reduce your carbon emissions? Obviously, it's becoming more and more of a hot topic. So in 2021, we said, okay, well, where do we actually sit? We were involved in the industry average EPDs, providing information for that. So we wanted to do our own to see, okay, what is our baseline of where we are today? How do we compare to the industry average? And then we can analyze also where the emissions were coming from through that and say, okay, how can we reduce them? What is our major contributors to the carbon emissions and how do we reduce that? So that was in 2021, we issued our first set of EPDs. Then over the last couple of years, we had major number of changes, switching over to PLC cements, increasing the use of supplementary cementitious materials, optimizing our concrete mixes, And then we've implemented new processes that can actually capture some of our waste heat, and we reuse that heat for accelerated curing of the concrete in a precast world. Obviously, we want to strip every single day. We need to accelerate cure our concrete. So we're actually capturing waste heat and using less natural gas as a result to do that. So EPDs normally are good for 5 years. It had only been 3 years since we've done ours, but due to some of these changes we made, to say, hey, let's redo ours because we can actually show this and decrease and put that information out there as well. So basically in 2024, that was last year, we said, okay, let's redo our EPDs. We also went much more in detail with these as well, into very separate categories. So we have 7 EPDs now at Stubbe's Precast, hollow core, flat wet cast, which includes all our balconies, solid slabs, and landings. Structural wet cast, which includes the beams and columns that we do. Structural walls, cladding walls, and then insulated structural and cladding walls. So we have 7 total EPDs to kind of break that down, which you'll see later on when you do a whole building LCA, why that's important. The very first time we did our EPDs, we hired a consultant to do them. This time around, we said, okay, let's do them ourselves. And we looked at a few programs. We settled on One Click LCA. That way we could do the EPDs in-house and then just get them third-party verified by an external party. We used ASTM for that. But yeah, there's other ones out there as well. One of the big benefits of using One Click LCA and doing it yourselves is then you can start to run different scenarios as well. You're not relying on a consultant all the time. So we could take a look and say, okay, if we're using a different supplier, what impact does that have on our EPDs? If we're changing a process and reducing our energy use, what kind of impact is that going to have? So with doing it One Click LCA ourselves, we can start to run different scenarios to see what effect different decisions are going to have on those final carbon emissions. So it's just showing some of our results here. You can see the CBCI, that's the Canadian Precast Concrete Institute industry average. They issued EPDs in 2015, 2019, and 2023, roughly every 5 years. And you can see the carbon emissions across the industry are reducing. And then you can see ours in 2021, and then in 2024, our recently ones that we just issued. So again, ours carbon emissions are decreasing. Again, that's a great thing we want to see, and we're staying below the industry average as a company as well. So those are the 2 things we're kind of targeting for is, hey, are we decreasing our emissions over time? And are we staying under the industry average? And that's kind of what we're targeting as well, to keep that momentum going and constantly seeing how we can reduce the emissions over time. So as you can see there, we're about, in just 3 years' time, we reduced our emissions by about 14.6%, and we're still about 6.7% below the current industry average. Then using the EPDs, you can really dive into the results a bit further. So here you have our 7 product types, our hollow core, structural wet cast, flat wet cast, and our different wall systems. And you can see where the emissions are coming from. So A1 is as Nick explained, is the raw material extraction and processing. That's our cement powder coming in. That's our rebar, any inserts that we use, lifting, all that stuff coming into our plant. Then you have A2, which is the transportation to our plant, and A3, which is our energy use at our plant, basically. So you can see that basically all these product types, A1, the raw material extraction and processing, it accounts for the vast majority of our emissions before it even gets to us. That counts for roughly, the A1 counts for roughly about 86% on average of our carbon emissions at Stubbe's Precast, of just before it even gets to our door. Transportation, only about 3%, very small amount. And then the actual energy use on our site about just over 10%. And then you can start to look and see, okay, the different product types, the different effect it has. So hollow core, you can see our carbon emissions on hollow core are only 168 kilograms of CO2 equivalents per ton versus structural wet cast, which is significantly higher at 278. And the main reason for that, as you'll see in the next slide here, is when we break down and see, okay, which materials are actually contributing to those emissions. So hollow core has very little reinforcing in it. It's a very low slump concrete mix with low powder content. So that's why hollow core is significantly lower than, say, structural wet cast, which is a heavily reinforced structural element with a lot of rebar, a lot of reinforcement in it. And you can see that green bar there, which is a reinforcing steel, which accounts for a significant portion of structural wet cast and the beams and columns, for example. And then a less of an impact on some of the other products like the flat wet cast, cladding, and structural walls, which don't have quite as much reinforcement as, say, a beam or a column. So you can really start to, with your EPD, once you do it, you can see, okay, where are your emissions coming from? Where are your hot spots? If you want to reduce emissions, what's the biggest thing you want to focus on to actually have the biggest impact as well? So for example, hollow core, we're roughly about 66% of our emissions coming from the cement. Obviously, we want to focus on, okay, how can we reduce our cement content, maybe increase our SCMs to reduce that, versus say a structural wet cast or a beam product, where maybe the focus could be on, can we find a different supplier of a rebar that's maybe lower emissions to actually have a bigger impact on that emission, the carbon emissions for that product, for example. So as I mentioned, using One Click LCA, you can start to run scenarios then. So after we did our EPDs, we got them approved, we went back to the model, basically create a model with One Click LCA. It has all your inputs in it. And we can start to say, okay, well, if we shift all of our reinforcement to one supplier, for example, on scenario 1 there, that is a lower carbon supplier or has a lower carbon profile of that reinforcement, we would actually reduce our carbon emissions for hollow core, say, by just over 8%. Now, scenario 2, for example, we looked at that same reinforcement supplier had a low carbon option. If we went and bought all our rebar to that low carbon option for hollow core, for example, we would reduce our carbon emissions by another 1.5%. Scenario 3, for example, we ran, okay, if we change our processes slightly, that would allow us to reduce another almost 5% carbon emissions. Doing a further change to a process, and I'm not going to get into too far what these processes were because that's a bit proprietary, but you can start to run analysis and say, okay, if we made a further change to our process, which would allow us to modify our concrete mix and do some other changes, we could almost see another 12% change reduction in CO2 emissions. And the final scenario we ran was if we switch to more grid power, we do create some power here with natural gas generators. If we switch more to grid power, in Ontario, we have a very low hydroelectric grid that's very low carbon emission and very friendly that way. If we made a bigger shift that way, we could save almost another 5% or just over 5%. So if we put all those scenarios together, we could actually reduce our carbon emissions by over 45% from 2021 numbers with our hollow core product, for example. So this really shows how you can use One Click LCA or other softwares like that to start to run, okay, it's another tool in your decision making and saying, okay, well, how can we reduce our carbon emissions? Obviously, there's a cost economic analysis that goes with this to say, okay, is it feasible too? But this is all technology. So these 5 scenarios I presented here are all available today that we could do today. Some of them require a bit of a capital investment, but where we could reduce our carbon emissions for a hollow core product by 45% from 2021, that we could actually reduce that today if we had that capital investment to do those changes. So you really can show that, yeah, once you have the information, the transparency, it can be another tool in your decision making of, yeah, do we want to go this? What's the cost difference? And what's that impact on your total overall carbon emissions to that product? So once we had those EPDs made, we wanted to take a step farther and say, okay, well, we know what our product is leaving our plant in terms of the carbon emissions per ton, but how does that relate to a whole building life cycle assessment or whole building LCA? And then we're located about an hour and a half from Toronto. So we said, okay, what's the standards out there that would govern what limits, and can we meet those limits with a total precast concrete building? The Toronto Green Standard has carbon emissions caps per square meter of flooring. They have a 3-tier system. Tier 1 is mandatory. There's no cap on Tier 1 right now for private construction. Tier 2 is set at less than 350 kilograms per square meter of flooring of CO2. And Tier 3 is less than 250 kilograms of CO2 equivalent per square meter of flooring. So we wanted to run this whole building life cycle assessment and take our results, compare them to the Toronto Green Standard to say, okay, where do we sit in terms of that, and how much work do we need to do possibly to meet that? The same time we were doing this, we had recently launched Fast Track by Stubbe's. So this is a new innovative approach to speed up construction and optimize the efficiency of building precast concrete structures. So we wanted to do it on a fast track building that would say, okay, this new way of building, how does that compare in a sustainable building environment? We hired a consultant to do this on a fast track building that was started construction this fall. That's probably about halfway done now. But yeah, it started construction this past fall. A little bit about Fast Track by Stubbe's. So Fast Track was developed to optimize construction to make it as efficiently as possible for precast concrete. So we could build fast, efficient, use less materials, and cut the construction timeline down as much as possible. Because we're optimizing precast efficiencies, we quickly realized that, hey, there is also a sustainability benefit here as well. Using less materials is going to relate to less carbon emissions, of course. In the pictures there, you can see McLeod Road. That was the one that we just finished. 5-story building, 50-unit building with 50 units in it. Took just 9 months to build. That's from starting excavation to move-in ready. So for the purpose of the whole building LCA that we hired the consultant for, we have our own development called Harvest Ave. There's multiple buildings on that site, but we just took building A and said, okay, let's run the analysis on this building and see where it lands. So it's an 8-story building, 132 units, 12,261 square meters of gross floor area, located in Tillsonburg, Ontario, which is about an hour and a half, 2 hours outside of Toronto. And yeah, as I mentioned before, the objective of that report was, okay, what is the carbon emissions per square meter of flooring for this building? And how do we compare against, say, the Toronto Green Standard out there? The scope of the study, as defined by the Toronto Green Standard, was we're going to focus on the upfront embodied carbon. So obviously you need to set, okay, what is the scope of the study for this building? So yeah, we were focusing on life cycle stages A1 to A5 for that embodied carbon of what it would take for carbon emissions to build this building. As mentioned before, A1 to A3 is the manufacture of it. A4 is the transportation to get to the site, the construction site, and A4 is the emissions on site for that, to actually build that building. The data sources used, so obviously this is where your EPDs are going to be really helpful. So if you have manufacturer-specific EPDs, that can really make your whole building LCA that much more accurate. Instead of using industry averages, if you know the manufacturer of your component and they have an EPD, you can get more accurate data for a whole building analysis. So obviously we used our new EPDs for all our precast concrete elements for this, and all the other elements, again, that's when we're going to use industry averages where applicable, or manufacturer-specific EPDs for very similar products if industry average EPDs were not available. And this was all done by the consultant, of course, to select the most appropriate EPDs if one was not available that would most represent the product in that building, whether it's drywall, the windows, the steel stud, whatever it might be for that building that wasn't part of our precast scope. Methodology in this, obviously you need a whole material takeoff. So we use the issue for construction drawings to do a complete building takeoff for all the materials that had to be included under the Toronto Green Standard for the structure and envelope. So that includes all the structural components, all the cladding walls that are part of the envelope, including anything attached to those walls. So all the drywall, steel stud attached to both the structure and envelope would be included with that as well. So here you can see the results. So as you can see, Harvest Ave came in with A1 to A5 at 220 kilograms of CO2 per square meter of flooring. As I mentioned before, the Toronto Green Standard has voluntary limits for Tier 2 and Tier 3 as shown there at less than 350 and less than 250. So at 220, we're meeting even the most stringent requirements currently in the Toronto Green Standard at 220. So it's even over 10% less than the most stringent requirement. So this is what we were expecting to see, considering the efficiencies of using precast and building with Fast Track. So this shows that we have a strong alignment with sustainable building practices and green building standards when we're building with total precast buildings, total precast concrete buildings. Same thing with EPDs. You can do in a whole building LCA where you can see a whole breakdown and you can do different analysis. So with a building, majority of your embodied carbon comes to the manufacture of the building products. The building obviously takes a lot of materials to build, no matter what you're building it out of. So there you can see about 92% of the emissions of this building comes from the products to actually build that building. The A4 is your transportation to site. That only accounts for about 1%. This construction site was only about 50 kilometers from our precast plant, which obviously helped with that a little bit. But your transportation to that site was very minimal in the overall total of the carbon emissions. And the A5 emissions, these were estimated by the consultant based on the NRC National Whole Building Life Cycle Assessment Practitioner's Guide. Definitely, there's still some gaps in how do you calculate on-site emissions, how do you capture that. So that was an estimate. I think it was based on about 6% of your building. However, we believe that with precast concrete, it's all pre-made in your factory. It's being assembled on site in a very short time frame. Your site emissions to actually build it would be most likely significantly less than, say, traditional construction where you're taking months, if not years longer to build the same building. Plus, with installing windows in our plant, we can close that building off immediately, so there's less hoarding, less heating requirement while we're building it, even if we're building it in the middle of the winter. And then through the whole building LCA, you can start to get a breakdown to say, okay, which components, which building materials are actually contributing, and what's their effect to the total embodied carbon in that thing there. And that figures there is a bit small, but basically it shows that for hollow core floors, the flooring system accounts for about 26% of the carbon emissions, the structural walls about 26%, the cladding walls another 9%, and the foundations about 10%. And then about 30%, 29% is all the other components, the steel studs, the windows, the drywall, all the other components, the insulation, for example, would account for the remainder of that. So then we can start to see, okay, where's your biggest contributor to that building? And if you want to reduce the carbon in that building, which of the materials should we be focusing on that's going to see your most effect to actually reducing those carbon emissions? As I mentioned in one of my previous slides, we went through that hollow core scenario to say, okay, if we ran and did these scenarios, we could reduce our emissions significantly on a hollow core product. So if we actually applied that scenario to this building, which I did earlier in analysis, we could actually reduce our emissions by another 21 kilograms of CO2 if we were to make all those changes in our plant, which would put this at under 200 kilograms of CO2 equivalent per square meter of flooring in that case. Obviously, this takeoff was done on the issue for construction drawings. We are tracking the materials that are actually going into build this now, so we can actually compare to the actual materials used to what we had estimated to make sure that, are we going to be close? For example, we looked at our foundations just recently. We used about 7% less concrete than we had assumed, so that's even going to bring this down a bit further. And our foundation, we had assumed that we were going to use 25% slag replacement on our concrete mix for the foundation. In reality, we used a 15% slag replacement mix. So those changes would actually reduce the consultant's analysis by another 5 kilograms of CO2 equivalent per square meter of flooring on the actual build. So as we build this building, we're going to keep tracking those actual material quantities that we're using to compare them against the initial report to see if, are we going to meet what we assumed, or will we be even lower than that? That's basically a bit about Stubbe's Precast, the product EPDs, how the product EPDs can be used to do your whole building LCA, life cycle assessment for a whole building, and then how you can look at hotspots a bit and how you can use those to inform your decision making for what materials you want to use or how you want to reduce carbon emissions going forward.
Great. Thank you so much for that, Stephen. Really informative. Loved all those graphs. And we actually have quite a few questions, so we will jump into those in just a second. Before we get to your questions, though, I have a question for you in the audience. Nick talked a little bit about how One Click LCA can help you with your EPDs, and then hearing this sort of real world scenario. If you would like to know more about how to create an EPD, if you're interested in using One Click LCA software, or you want to know more if you are in the AEC sector and you want to know more about sourcing materials with EPDs or getting those low carbon materials, I'm going to put up a poll right now asking if you would like a demo. If you want us to contact you, just say yes. And then if not, you can just say no, and you can learn more on our website, oneclicklca.com. But for now, you should see the poll in the middle of your screen. So do let us know if you want us to reach out and schedule a demo with you. We'll be happy to do that. And we have your email from your registration, so we'll be able to reach out to you and get that set up. And so while you guys are answering that, we will jump into the Q&A. I'm going to make our screens a little bit bigger here. So like I said, we have quite a few questions. First is the question is about which industries in Canada specifically currently use EPDs. There are EPDs that exist in construction. Are other sectors using EPDs? Nick, you might want to answer this, or Stephen, if you have any insight as well, because I know you're in Canada.
Yeah, I can jump in at least first. Classically, what we have seen is both a market and a federal push for these EPDs for different reasons. So that's kind of the pushers and drivers. Construction is under a lot of that sight by those movers because, as I mentioned earlier in the call, construction is a huge portion of these embodied carbon emissions. So that's kind of why we want to tackle the biggest one out there. Some other sectors are going to be, consumer sectors. There's laws in California right now. Senate Bill 253 is requiring companies over a certain size where you need to start disclosing this type of information, and EPDs would be part of that, or at least doing the life cycle assessment for some of your products. So pretty much California and large companies, that screams tech to me. So tech industry is definitely going to be one of those, and really construction tech, but anything under the sun can have an EPD.
Thanks for that. And sorry.
Yeah, I was just going to pass it to Stephen if he had any information on Canada on that side, if they were any other industries you see popping up outside.
Yeah, in Canada, there's no requirement to do an EPD, essentially. Obviously, businesses and sectors are starting to do it more and more just to see where they're at, show that how they can reduce them. So yeah, a lot of our cement plants, for example, have our EPDs. A lot of our rebar manufacturers have EPDs now. But yeah, it's more market driven at this point. I don't know of any specific requirement where it's mandatory in any sector in Canada that I know of. But yeah, it's more market driven. With people doing more and more whole building LCAs, obviously there's more and more requests for EPDs, which are driving the market to do them in all, for whatever product you might be supplying to that building.
Great, thank you. And then this was a two-parter question. So Nick, I'll ask you this because I know you work with a lot of different materials. The question is about, are there any specific organizations that issue more authoritative EPDs? How can a person choose the most authoritative EPD from the various organizations that publish them on the market? And I know a lot of that depends on what material you're looking at, but Nick, if you could give us some insight there.
Yeah, completely. So I like to most authoritative. That's definitely, it's hard to pinpoint what's more authoritative than not. But what I do know is what is more accepted by kind of the industry and what is typically not accepted. So right now, what is typically accepted is called third-party verified EPDs. So this means that another organization had reviewed it and ensured that it had aligned to whatever standards and rules that it needed to. And then and only then, once it's okay, it gets published on those various organizations. So I want to particularly stick with an organization, I would say more actually getting that verification is setting you on that path of having the more authoritative EPD. And then from that point, your organization can depend on which way you want to go. And that's going to be driven by your clients who are requesting this EPD. Is it a federal? Is it a private sector? Do they have specific rules that you need to follow? Do you not? All that is very important. But I think the heart of it is getting it verified. To get a third-party verified EPD, that's the most kind of rigorous, authoritative, robust EPD, I guess to say.
Great, thank you. Stephen, this next question is for you. And this got posted up when you were showing the chart of the different scenarios and different ways you were able to reduce carbon. So without going into proprietary information, are you able to talk a little bit into the general types of process changes that you looked at to reduce those emissions in the hollow core scenario? Was this focused on increasing cure time, for example, or to make up for the slower cures associated with low carbon mix designs, or was it more to do with the mix design itself?
Yeah, so I had 5 scenarios there. The first 2 were just, selecting different suppliers. The next 2 interchange from process, I believe was the next 2. They were related to, do we have a slightly longer cure time? Is there different admixes that we're researching now? There's different admixes you can do that would help speed up that cure time with using maybe higher SCM amounts, for example. So while using an accelerator or different types of admix, you can get a faster cure time, even though you're using maybe a type 10 cement or an SCM, for example, that would slow it down and offset that slowing down to still hit your cure times that we need to in the precast world, that we can turn our forms around as often as we want to and optimize that plant.
Great, thanks for that. Another question for you, Stephen. Do you have an order of magnitude of how much your A1 to A3 results is a result of the concrete mix itself, and how much is due to other material like rebar, formwork, and processes like the curing process?
So just, this is for our EPDs of how much is related to the materials versus the energy used in our plant?
No, it's more how much it's a result of the concrete mix itself, or are there other materials that you're using that aren't part of that concrete mix, like rebar that you maybe were measuring, and then also processes, so sort of those 3 components?
Yeah, I believe in the one graph I showed that breakdown a little bit. So it really depends on the product. Hollow core, for example, because it's a long line specialized process, there's not much rebar or reinforcement in there. So I believe it was about 66% of emissions in our hollow core product comes from the cement powder, for example. But it's a low cement contact mix, so that product is actually significantly lower than all our other products because of that. Versus looking at a structural beam. Structural beams obviously need to take a lot of load. There's a lot of reinforcement in there. So I believe the reinforcement accounted for just as much or even more of the carbon emissions in a structural beam as the cement powder did in that or the concrete mix, for example. So yeah, it really depends on the product. And then I showed the A3 emissions, which would be that curing and all our energy use on site in our plant, which accounted for maybe about 10%, I believe, just over 10% of the whole emissions for a product was about 10% or just over. That the main is the actual raw materials coming in before it even gets to us that account for the carbon emissions.
Great, thanks for that extra insight. Another question for you, Stephen. Can you provide additional context as to how embodied carbon levels differ between equivalent cast-in-place concrete elements versus precast elements? What's generally lower up in Canada and Ontario specifically? And then just as a sort of note, they say that they understand precast elements would involve less site energy to install, but more energy at the plant. So sort of what's that overall footprint look like?
Yeah, that one's hard to answer because every building is different. And you can't compare an EPD for concrete ready mix to our precast EPD. A concrete ready mix is based on volume, and it doesn't include any of the rebar and the site emissions to actually build that product in the curing, for example. So they're very hard to compare. The only way to compare is try to take two very similar buildings and run that whole building life cycle assessment on it to actually get that information. It depends on the concrete mix they're using in a cast in place example, for example, how much rebar is in that, how many beams and columns and walls, for example. So it's the only way to properly compare two building types is to do a full building LCA on a buildings that are similar enough that you can make that comparison. And even then you're going to have people saying, yeah, that they're not the same because every building is very different. So yeah, we took the approach in our analysis was let's just compare ourselves to a standard out there that we can compare ourselves to see, can we meet that standard today? And if not, what we need to do, obviously we can meet it today. And we're still looking at, how can we even reduce those emissions even more? But yeah, trying to compare two materials can be very difficult because they're used very differently in that sense.
Got to do a life cycle assessment on both buildings and get the full picture every time. One more question for you, Stephen. Are you using BOF or EAF steel? And is this part of the optimization options that you looked at for rebar?
I would need an explanation of what is BOF or EOF steel. I can say that we just use regular black reinforcing steel. We use pre-stressing strand, for example, for the pre-stressing in our products, and then just regular rebar from various suppliers that we have access to.
And if I may, I believe they're referencing blast oxygen and electric arc furnace. So
that would be supplier dependent. I'd have to look into it. We use a couple different suppliers, and the analysis we looked at was just to look at that supplier and the EPD that they have, and using that information to say if we only buy from this supplier that has a low carbon footprint, which they might be using an electric arc furnace to get that, I don't know. That would be would show up in that manufacturer's EPD, obviously, to get that information.
Great, thanks for that clarification, Nick. And how much minimum time does a concrete plant need to prepare a concrete mix of a certain global warming potential? What's a good rule of thumb to allow enough time for the plant?
Yeah, if a architect or owner wanted just a GWP of a concrete mix for a certain project and didn't want it third-party verified, it wouldn't take very long, maybe a couple weeks. But if you have to go through that whole verification process, it can take a couple months, for example. So that's generally why you do an EPD based on a calendar years of data. For example, our 2024 EPD that we issued was based on our 2023 operating data of all the materials we brought in and our energy use. And that 2024 EPD that we issued is based on a whole year's of data. And we wouldn't really do a specific project EPD at this point, unless we had a very specific requirement. We could maybe take a look at that, but it wouldn't be third-party verified. Otherwise, it's gonna, they're not cheap to get verified, and they too take a lot of time to do it the full proper way to do that. I would say the one benefit of One Click LCA, now that we have the model, if we had a request to say, hey, can you use more SCM in our project, we would be able to run that fairly quickly using the model we currently have and just substituting the ingredients based on maybe an increase of, say, 10%, and what that would look like. It also does allow us to, with using One Click LCA now, and I just started putting our 2024 operating data into the models we had from last year to say, okay, how did we compare from last year? Probably not going to get them verified, but every year we can just throw our data in now and see how we did to the previous year. if we see enough of a change, that's when we might say, okay, let's get it re-verified and reissued, maybe before that 5-year period, just to get that new information out there if we do see a massive change in our carbon emissions year over year.
Yeah, great. We've got the questions keep coming in. We only have time for a few more. One of them is that a cement looks like it's the most impactful CO2 ingredient in your LCA, which is not too surprising. And are you doing anything to get that number that's contributed from cement down over the next year?
Yeah, so obviously we're continuing to look at different options. It's going to change from year to year depending what technology is available. I know the cement industry there's many things going on, longer term research on how to decrease that, to increase in the limestone content, for example, from 15% to 20 or even 25%. Yeah, we're looking at, obviously you constantly look at optimizing your mixes. Can we run higher SCM percentages? And some years there might not be a change. I know last year we fully completed the switch to PLCs, Portland limestone cement everywhere in our plant. So that would show in our based on our 2024 operating data, we'll actually see a bit of a decrease from the previous year probably. And we'll just continue to look at any advantages. I know we're doing some research and development with different admix companies, testing out maybe graphene, for example. And as new technologies come out, we continue to help our raw material suppliers with testing and doing some things for them to say, hey, does this work? Does this not work? So we're definitely involved with our suppliers in certain areas to say, hey, how can we help you with testing in a real world environment to see if new technologies are going to work or not?
That's great. And you mentioned this in your answer a little bit, but the next question is what's the typical percentage of SCMs in your mix? I know you said you can increase those. But what are you typically using now?
Yeah, it depends on the product. Some products we can't use much at all, depending on what the product is, and then other products up to 20, even 25%. Yeah, I'd say some products were up to 25%, even maybe a hair higher in some. Obviously, cure time has the biggest effect in a precast plant. If we can't strip in the morning, then we have a whole crew of people in form sitting there doing nothing for a day. So yeah, we'll continue to optimize that, but yeah, definitely up to 25% in some products we can do fairly easily at this point.
Great. And then last question is this case study LCA published and available for download?
Our EPDs are published and verified by a third party. The whole building LCA done by the consultant is not formally published. If you reach out, we can definitely share it, and I'll see about getting that put up on our website as well, maybe on our stubbies.org website as well. We've shared it with a number of people that have asked for it, and we'll definitely get it out there more formally, I guess, to get that information out there.
Perfect. Well, thank you so much. Thank you both for taking the time. I think this was really an insightful discussion, and as you can see, lots and lots of questions. So definitely some good discussion with our audience. Thank you so much, Stephen, for your time and sharing your insights today. And if you guys in the audience want to keep the conversation going, of course, you can find both Stephen and Nick on LinkedIn. And you can always reach out to One Click LCA. You can email us at sales@oneclicklca.com with any questions that you have, or if you want to keep the conversation going. So thank you again so much for your time, both of you. Any sort of last notes that you want to say before we sign off today? And Nick, I'll start with you.
Yeah, my only note is, whether it is a requirement or not, soon it will be. Whether it is for the private or federal sector. So starting early, starting soon is always kind of best, as that data collection is kind of the longest time. But once you get that first model, it can be a very quick change to be able to push those out. So start early, start often with all your products. That's my take on it.
Great. And Stephen?
Yeah, just thanks for everyone for attending. Hopefully it was insightful. If you have any questions about EPDs and our process and want more information, definitely reach out. yeah, agree with Nick. EPDs really help with another tool in the decision making of looking at raw material suppliers and which ones might be more greener that you might be considering to, and helping your suppliers also and driving down those carbon emissions everywhere, all the way upstream and downstream as well. So definitely it's a useful tool for transparency of seeing where you are. There's still lots of research and stuff and gaps that need to be filled yet, but it's ever evolving and it's interesting to be part of. So thanks for everyone, and hopefully you found it very useful.
Fantastic. Well, thank you guys both so much. Thank you to our audience for joining us today, and we will see you on the next one.